Welcome back to AQA GCSE Engineering. Today we'll be going through 1.1.3 Composites. Here's today's spec. Before we look at some examples, what are composites? Composites combine materials with different properties to get a resulting material with superior properties. They compose of reinforcement and a matrix, and it's usually made by brushing or pouring the matrix into the reinforcement. The reinforcement provides the main strength and stiffness of the material, while the matrix binds the reinforcement together and gives it a shape while protecting it. As part of the spec, you need to know how changing some components affects the overall properties of the composite. Firstly, we have the alignment of reinforcement. Composites are strong when force is applied parallel to the reinforcement and weak when force is applied perpendicularly. And that's why oftentimes the reinforcement will be woven at certain angles. In terms of the amount of reinforcement, increased reinforcement increases strength, stiffness, and hardness, while decreasing toughness, making it easier to form fractures or cracks. In terms of the size and shape of reinforcement, continuous fibers provide high tensile strength and high stiffness, but crack easily. Short fibers or particles are tough, wear resistant, and crack resistant. Platelets are strong in many directions and are also crack resistant. The type of matrix can influence the chemical, thermal, and electrical properties, and it also influences the toughness and hardness of the composite. For example, if you choose a metal matrix, then it will be thermally and electrically conductive. Whereas if you chose a polymer matrix, it would be thermally and electrically resistant while providing some flexibility. Moving on to the examples. As usual, don't try to memorize all the properties. Think about the use cases of each material and work backwards to figure out the properties. CRP, or carbon fiber reinforced polymer, is made of, carbon fiber and some kind of resin. CRP is known for its high strength to weight ratio and is corrosion resistant. This makes it perfect for the best quality aerospace, automotive, and sporting equipment. However, its high production costs, labor-intensive nature, and repair challenges make it limited in widespread usage. GRP, or glass reinforced polymer, is made from glass fiber and some kind of resin. It is strong, low density, has good chemical and temperature resistance, and is smooth. This is why it's used for boat hulls, water tanks, surfboards, and canoes. However, like CRP, it's also laborious to make and difficult to dispose or recycle. Plywood is made from wood veneers. These are thin sheets or slices of wood cut from the wood bark. It also uses epoxy resin as its matrix. It is strong, versatile, and smooth, but may warp in moist environments. This is why it's mostly used for interior applications, such as flooring and furniture. It can also be used in construction. MDF, or medium density fiberboard, is made by compressing sawdust or wood fibers and again binding it with resin. MDF is easy to machine, smooth, and it's easy to paint. That's why it's used for decorative applications like furniture and paneling. However, it can crumble in moist environments and has weak screw holding. It's also not for heavy loads. OSB, or oriented strand board, is made from wood strands or wood chips. And just like all of the composite materials that we've seen so far, it also uses resin as its matrix. OSB is uniformly strong and smooth. However, it can warp in moist environments and may be aesthetically displeasing to some. It is similar to MDF in a sense that it's a cheaper replacement for plywood, and that's why it's used in furniture as well. However, its greater strength means it's used in more structural applications, such as sheathing walls or roofs, or even subflooring. Finally, we have structural concrete, which composes of steel bars as the reinforcement, and for once, the matrix is not resin, but is instead cement. Structural concrete has excellent compressive strength, is very durable, and can be molded. That's why it's used very widely in construction, making bridges, highways, or buildings. However, it's susceptible to cracking, and its manufacture contributes greatly to carbon emissions. That's about it for today. As usual, relevant resources will be linked in the description. Thanks for watching.